रच्चू आज हम बात करेंगे लीनियर मोमेंटम ऑफ अ सिस्टम ऑफ पार्टिकल्स टॉपिक के ऊपर। तो चलते हैं। लेट अस कंसीडर ए सिस्टम of n particles with masses m1, m2, mn moving with velocity vector v1, vector v2, dash and vector vn respectively. The particles may be interacting and have external forces acting on them. The linear momentum of the first particle is vector v1 is equal to m1 vector v1 of the second particle is vector p2 is equal to m2 vector v2 and so on.
हाँ बल्ला सोई तुमने कि बिस्किट खाएगा तो बाहर नहीं करे पीले
वो था for the system of polar system of n particles, the linear momentum vector p of the system of the system is the better sum of linear momentum of all individual particles. जी, particles of the system of the system vector P equal to P1 plus vector P2 dot vector Pn. ऐसे हो जाएगा वेक्टर P इक्वल टू M1 वेक्टर V1 M2 वेक्टर V2 प्लस Mn वेक्टर Bn if M is the total mass of the system of n particles and n particles concentrated at the center mass at the center of mass and vector B is velocity of mass center of mass. Then vector P is equal to M vector V. From equation first and second M B vector is equal to हो जाएगा M1 B vector M2 vector V2 plus Mn vector Vn. Hence the total linear momentum of a system of particles is equal to the product of the total mass of the system and the velocity of center of mass. differentiating equation. Second, with respect to time, we get dp vector upon dt is equal to m dv vector upon dt. यहाँ से हो जाएगा m वेक्टर a और यहाँ से वेक्टर एफ एक्सटर्नल और डी पी वेक्टर अपॉन डी टी आ जाएगा डी पी वेक्टर अपॉन डी टी कितना आ जाएगा वेक्टर ऑफ एक्सटर्नल ए. दिस इज द statement of Newton's second law extended to a system of particles. In an isolated system, the vector sum of external forces acting on a system of particles is zero. Therefore, d vector upon dt is equal to 0. Zero or vector p is equal to constant. A dash m vector p is equal to constant. Therefore, vector p is equal to constant. A dash velocity of center of mass remains constant when total center of force on the system is 0. In an isolated system, the vector sum of external forces acting on a system particle of particles is 0. Therefore, dp vector upon dt is equal to 0. तो यहाँ से वेक्टर p is equal to constant. Just m b vector is equal to constant. Therefore, vector b is equal to constant. Rest velocity of center of mass remains constant when total external force on the system is 0. Note that on account of internal forces, just the forces exerted by the particles on one another, the individual particles may have complicated paths Yet, if the total external forces acting on the system is zero, the center of mass moves with a constant velocity. It just moves uniformly along a straight line like a free particle. If the center of mass is at rest, it should remain at rest when total external force acting on the system is zero. Note that equation vector p is equal to constant implies that px is equal to c1, py is equal to c2, and pz is equal to c3, where px, py, pz are the components of total linear momentum vector p along x, y, z, x, and c1, c2, c3 are constants. Equation equation 4 implies implies that px is equal to c1, py is equal to c2, and pz is equal to c3, where px, py, pz are the components components of total linear momentum momentum vector p along x, y, and z axis, and c1, c2, c3 are constant. Constants